Okay, so today we are going to start the algebra, which is the chapter 11, excuse me, the part of chapter 11. So we'll talk about algebra, and we'll also talk about the chapter 12, which is again about the algebraic expression. So I think many of you have been exposed to algebraic expression in math class. So algebraic expression is something where you have numbers, you have letters, you have operators like this one. So it can be something like this. For an example, you have 3x plus 2xy minus 7. As you can see, there are some numbers, there are some letters like xy, and there are some operators like plus and minus. But remember, there will be no equal sign in algebraic expression. Okay. So, but if you have an equal sign, that will be an algebraic equation. Again, in equation, you have two different expressions in both sides of the equal sign. Okay, and both of the expression will have numbers. They might have x, y letters, which are also called variables, and operators like plus, minus, multiplication, division, power, root, all the different powers. All the letters we have, those are, we call them variables, and in some cases we call them unknown, based on whether we know their values or not. But those letters or variables are used to basically represent some sort of relation. Okay. For an example, let's say if you have an equation like 3x equals to 3, where x is unknown, but if you solve the equation, I'm saying if you try to plug the value for x, let's say for an example here, it will be 1, right? Because if you multiply, because 3 times x equals to 3, that means x must be 1, and that's why 3x equals to 3. So again, there are operators, and between the operator, I'm saying between one operator, there are, these are called terms. Like for an example, 3x is a term, 4xy is another term, 2 is another term. So you pretty much have 3 terms in this algebraic expression, right? Coefficients, all the numbers are basically coefficients, okay, whatever the number you have. So for an example, in 3x, the coefficient is 3. If you have only a letter or variable or an unknown like x, y, a, b, so still you assume there is a coefficient, let's say, which is 1 here, because y is basically 1y, right? If it is a, it's basically 1a. So 25xy, the coefficient is 25. These are all the examples. And also, to work with the algebraic equation or expression, we have to understand the like terms. Like term means their coefficients are different. Other than the coefficient, they're pretty much same. For an example, let's say 33x and 4x. If you see both of these numbers there, both of these terms, they have x, right? Both of these have x. The only difference is the numbers are different. One number is 4, another number is 33. So they are basically like terms. Now here, 3x squared and 5x squared, they are like terms as well, because their x squared is same. The only difference is x 3 and 5. Next one is same. Their numbers are same. They have different sign as well, but they are still like terms because the variables are same. 2 and 4 like terms. But look at this one, the last one, 3xy and 7y, they are not like terms. Basically because they don't have the same variables. 3xy has x and y both, but 7y has only y. So they are not like terms. We have to understand the like terms because we have to understand the like terms because whenever you do the addition, of meaning any kind of operation, addition, subtraction especially, you need these like terms. Now, here you go. So for the addition and subtraction, the important part is we can only add or subtract the like terms. If they are not like terms, we don't run up any operation between them. We just keep them as it is. Okay. So And remember, don't forget, if you have a letter or variable without any coefficient, still the coefficient is 1. Now, for an example here, 3x plus 5x. If you add them, excuse me, first of all, they are like terms, right? They are like terms, so you should be able to add them. If you add them, their variables will be exactly same. The only thing that will be changing is the number. So it's basically 3 plus 5 is 8. So the answer is going to be 8x, which is B, right? That is B. 2y plus 10y minus 2y. It's all these are like terms because all these have the same letter. If you add and subtract, you'll end up with 10y, right? So the right answer is A. How about this one? If you look at carefully, there are 2x and 3x. They are like terms. If you add them, you'll get 5x, right? And 4y and negative 2y, they are like terms. If you subtract, you'll get 2y. It will be plus 2y because 4 is higher and it has plus, so the answer will be C. How about this one? First 3 terms are basically like terms, right? Because they all have x and y. If you add, it will be 9xy, and you will keep the 2y as it is, right? Right answer is A. Next one. Okay, here, first 2 terms are like terms, right? So you add them, it gets 6x squared y. And next 2 terms, the last 2 ones, they are unlike, right? So you keep them as it is. So the right answer is D, last one. Yeah, what is it? Why did I add what? These ones? Oh, the last one? Exponents, you add the exponents only when we multiply. That's the rule of the multiplication. So these are additions, right? If you multiply them, we will show you the multiplication, but if you multiply, then only add the exponents. Okay? We'll show you. Now here, again, the like terms are 8n and 3n, negative 3n. That makes 5n. And also 3, 5, negative 2, those are like terms as well. Okay? Then you get 6 from there. So the right answer is 6 plus 5n, which is the last one, D. Right? Okay, now here you will see that how we do the multiplication and we add the exponents. So when you multiply, again, you don't care about the like terms. That's the good news because we don't have to care, but multiplications are done between the variables, between the numbers, between everything. Same is true for the division as well, okay? So law of exponents, again, this is probably for you. The law of exponents says that add exponents when you multiply and subtract exponents when you divide, okay? So for an example, let's say the first one is 6z over 2. So you don't have, I'm saying you have only one z, so you keep the z. So 6 over 2 is 3. Here 2x over 3 is, I'm saying 2x times 3 is 6x. 3x times 4y equals to 12xy. Now so far, we haven't seen anything which has same term and then I'm saying same variable you are multiplying, okay? Now here you can see that we are multiplying 2x times 3x. Now you see we are basically multiplying 3 times 2, that will give you 6. And then x times x. Now the x, both of the x has an exponent of 1, right? Look at this, we are adding the exponent. So this is the time we add the exponent, so it will be 6x squared. The division, we subtract the exponent. We subtract the bottom one from the top one. Now in this case, both of the exponent is the same, are same. They both are 1s. We subtract And remember the last, I think in some lecture we said that anything to the power 0 is 1, no matter what it is. So it's y to the power 0, of course, is 1. So the answer is 3. Next one, 12y squared divided by 4y. So you are basically subtracting the power of y since this is the division. The bottom one, the power is 1. The top one, numerator, the power is 2. So you subtract 1 from 2, it will be 2 minus 1. So you will be left with only 3y. Okay. Let's see some examples. 2m times 3m times 4m. Now this is a multiplications, because remember sometimes multiplications are represented in terms of given in terms of parentheses, right? So we multiply the numbers 2 times 3 times 4, which will be 24, and then 3m. So they all have exponent of 1. You add them, exponent. So it will be m cubed, right? So 24m cubed, the right answer is C. Right? Let's look at another one. Now this one, you again multiply all the numbers, so it becomes 24, but now you have 2 m's and 1 n. You keep n as it is. You will be multiplying the both m, so it will be m squared there. So the right answer will be D. 24m square n. Any question here? Let's check another one. 10y squared divided by 2y. You divide the 10 by 2, then you get what? 5. You subtract the power, right? Because this is a division. In the numerator, your power is what? 2. Denominator, your power is 1. So you subtract 2 minus 1. Then you get y to the power 1, which is y. So the answer will be 5y. Right answer is B. Again, if you multiply, power gets added, right? If you subtract, power gets subtracted. This is the last question. I'm saying just this is the question before the last one. So let's see. 20 y to the power 5 divided by 2 squared. 20 by 2 is 10. Now in case of y, what happens? The power of y is 5. You subtract 5 minus 2, that's y cubed, right? So the answer is 10y cubed. Right answer is A. Let's check another one. 40 divided by 2. 20, right? Now look at this one. You have y and x both. So you'll be dealing the power of x's and y's separately, right? Power of x cubed and x1. So it will be like x to the power 3 minus 1, right? And y to the power 5 minus 2. So what happens? You get 20 x to the power 3 minus 1, y to the power 5 minus 2. Then you get 20 x squared y cubed. So the right answer is D, last one. Any question here? Okay, this is a very short introduction of introduction of algebra. We'll stop the presentation of chapter 11 here, but then we'll move on to chapter 12, which is again about the algebra and algebraic expression and equations. Okay.